Your friends have more friends than you do. Today, I'll show you that this unfair-sounding sentence is a mathematical inevitability. Let's begin. It may sting a little, but it's a true story. Don't worry, there are no scary formulas here. Our only tools are addition, division, and one change of perspective. In return, let me make you one promise. If you watch to the end, you'll see that this sentence on screen was a mathematical inevitability. The first time you hear it, it feels a little unfair. And yet, somehow, this feeling seems strangely familiar. Whether you're scrolling Instagram or you're messaging apps, doesn't everyone around you seem better connected than you? But here's the truly absurd part. You are not the only one going through this. When researchers examined the entire network of roughly 720 million Facebook users, a staggering 92.7% were in this exact situation. That's more than 9 out of 10 people, each feeling like they alone are the less popular one. This is the famous friendship paradox, formalized in 1991 by sociologist Scott Felt. Today we'll dig to the root of this injustice using just one idea. What exactly are we counting? And by the end we'll see how this paradox catches epidemics 2 weeks early, and why social media makes us feel small. But before we go there, there's one thing we need to clear up. First, let's clear up a misunderstanding. This does not mean you're unpopular. Not at all. It's easy to get discouraged and think, I knew my circle was small. But is that really true? In one Twitter study, more than 98% of users were experiencing this paradox. Even people in the top ranks for followers and activity found that the accounts they follow were doing better than they were. If even the people at the very top of the popularity ladder can't escape it, the culprit isn't the people. It's the way we count. But one more thing is strange. Friendship is perfectly symmetric. If I'm your friend, then you're my friend. In a relationship this symmetric, how can almost everyone tilt toward my friends have more at the same time? Surely not everyone can be below average, right? This very mismatch is the heart of the friendship paradox. And the key that unlocks the secret lies in a single phrase. What are we counting? Picture a small class. There's Minjun, the popular kid who's friends with everyone, and Quiet Jia and Sua, who each have only a friend or two. Let's tell two questions apart. Question A. Grab any random person. How many friends do they have? Question B. Pick any friendship at all and look at the person at its end. How many friends does this person have? Sounds like no big difference, right? But they're completely different. Because the popular kid shows up on countless friend lists at the same time. Someone with 40 friends appears on 40 friend lists. Someone with just one friend appears exactly once. So when you count through friendships, popular people get picked as many times as they have friends. They're overrepresented. Let's check with a 6-person network. The yellow circle in the middle is Minjun, the hub with 5 friends. Jia's only friend is Minjun. And Minjun has 5 friends, so the friends average Jia sees is 5. What about Seojun? His friends are Minjun with 5 and Haeun with 3. His friends average is 4. Counted this way, 4 out of 6 people fall into the paradox. Only Minjun is the exception, and Haeun exactly ties her friends' average. The bars on the right are the verdict. The average over people is 2.3 friends, but counted through friendships it jumps to 3.1. Same class, we only changed how we count and the average went up. Because Minjun slips into 5 lists 5 times. Whenever you're on someone's friend list, the popular people show up on that list more often than the rest of us do. And the secret that the gap next to those bars equals the variance divided by the mean, we'll reveal that in Chapter 4. One little toy diagram probably won't convince you, so this time let's put it to the test on real networks. This time we take each individual's point of view. For every single person we compare their own friend count with their friend's average friend count. We have 2 test beds, a real 1970s karate club with 34 members, and a simulated social media style network of 1,000 people. First, how to read the chart. Each dot is one person, and the dashed line is the break-even line where you and your friends come out exactly equal. Above the dashed line means your friends are more popular than you, and the dots are crowded overwhelmingly above it. In the real karate club, 29 out of 34 people, 85.3%, lost out to their friends. In the social media style network, 88.8%. The same pattern as the Facebook figure of 92.7% we saw earlier. Let me point out just two things here. First, it's not half, a staggering 8 to 9 out of 10 people experience it at the same time. Second, way out on the right, even the superstars with dozens of friends, a good number of them still sit above the dashed line. So it's nobody's flaw. It's because the sample called My Friends is itself drawn tilted toward popularity. So what on earth decides the size of this gap? Too many popular people? No. The real culprit is something else. Now it's time to name the real culprit. What creates the gap isn't the average. It's the unevenness. Let me give you the conclusion first. Your friend's average is always bigger than your own, by exactly the variance divided by the mean. What if everyone had exactly the same number of friends? The unevenness, that is, the variance, would be 0. Then the added term is 0 as well. Whether the average is 100 friends or 1,000, the paradox vanishes without a trace. Conversely, the more uneven the world, some with thousands of friends, others with just 1 or 2, the fiercer the paradox becomes. Let's check it with a picture. On the left are the distributions of friend counts in the social media style network, counted in two different ways. Sample by person, and the average is 4 friends. But the moment you sample by friend, the whole distribution lurches to the right. Popular people get picked as many times as they have friends, so the average leaps from 4 friends to 11. On the right is this chapter's conclusion. We compared 3 worlds that differ only in how uneven they are. In the world where everyone's equal, the gap is 0. Slightly uneven, and it's 0.9 friends. In the social media style world, it widens to 7.2. The surprising part is that all 3 worlds have nearly the same average friend count, right around 4. One line captures all of this. The average friend count of your friends is mu plus sigma squared over mu. Since variance can never be negative, the friends side can never come out smaller, and they're equal only when everyone is exactly the same. Really? Plug in the 1,000-person social media style network. 3.99 plus 7.22 is 11.21. Fits exactly. And the social media we live on is the most uneven network in human history, the fiercest stage the paradox has ever had. A quick side story before we move on. As it turns out, the friendship paradox isn't alone. Feld's 1991 paper carried this title: Why Your Friends Have More Friends Than You Do. And yet the name friendship paradox wasn't his. It took hold in academia afterward. The class size paradox is even older. It's a phrase Feld coined together with Grofman in 1977. The 1991 paper folded the friendship phenomenon into this family. The family shares just one trait. The bigger something is, the more often it catches our eye. Take class sizes. The average is 31 students, but ask the students and average their answers and you get 56. Big classes hold more students, so counting by student overrepresents the big classes. Hemingway pointed this out in 1982. Buses are the same. The average gap is 8 minutes, yet somehow it always feels like you're waiting longer, doesn't it? A passenger who arrives at random is more likely to land in one of the long gaps. And this has a name: the inspection paradox. Sample in proportion to size and the average inflates. And this very trap is now saving lives. If this unfair paradox ended as nothing more than a story that hurts your feelings, we wouldn't have made this video. It may sound like a joke, but it's really true. The key idea is simple. Pick a random person's friend, and that friend sits closer to the center of the network. You don't need to know the whole network. One hop through a friend takes you toward the center. And that single step accomplishes 3 things. First, epidemic early warning. In 2010, Christakis and Fowler split 744 Harvard students into 2 groups. A random group and a group of friends they had named. The friend group sits at the center of the network, so it gets exposed to an epidemic earlier. Sure enough, during the 2009 flu outbreak, the friend group's infection peak arrived about 2 weeks earlier. Second, where to aim the vaccines. You want to stop the superspreaders first, but it's hard to tell who the hubs are. Cohen's 2003 solution is elegant. Instead of vaccinating a randomly chosen person, you vaccinate a friend that person names. Hubs get named as a friend by many people, so they fall into the net more often, all on their own. You protect the core first without ever mapping the network. Third, social media makes you feel small. Because the friendship paradox doesn't stop at the number of friends. In 2014, EOM and Joe showed your friends have more citations and more activity. And in 2017, Ballin confirmed the happiness paradox. Your friends look happier. Jackson even showed that peers drinking and smoking look more common than they actually are. The same mathematics catches an epidemic 2 weeks early on one side, and makes us needlessly gloomy on the other. Let's go back to that unfair sentence from the very beginning. My friends have more friends than I do. It's not that you're unpopular. It's that the sample called my friends is drawn with a tilt. And the size of that tilt is decided by one thing alone: how uneven the world is. Looking back at the tools we use today, there's really not much to them. Just two. One honest caveat though. The friendship paradox is a tendency on average, not an iron law without exceptions. The 85% and 89% we saw meant most people, not everyone. The yardstick changes the result too. Measured against your friend's mean, it's 92.7%. Measured against the median, it drops to 83.6%. Researchers consider the median the fairer measure. Let a single superstar into the mix and the mean shoots way up. So the next time you come across an average, take a moment to ask yourself this. That single question turns an unfair paradox into plain, calm arithmetic. So tonight, as you scroll past the friends in your feed, please don't feel too small. That's simply how the counting works. If you enjoyed today's journey, cheer us on with a like and a subscribe. See you at ELLSLAB for the next Odyssey.